Hi, my name is Chris Desatel, and this is a video about the basic steps in building a Windsor style rocking chair. This one right here, in fact. It's not an instructional video. It doesn't go into the level of detail needed for that, but there's plenty of instruction available. You can buy, there's plenty of books and DVDs you can buy that give you all the detail you need. This is mainly just to give you an idea of the basic steps behind this kind of build so that you'll know what you're getting into if you decide to pursue it. The video's unique aspects of the Windsor rocker. I just stick to the things that are unique to the Windsor architecture. Because I did a video of this Maloof rocker I'm sitting in, and I went into great detail on how I hand carve the seats. Well, that's the same tools and techniques for this chair, so I didn't go into that. I just skipped over that. Why be redundant? I did cover the styles quite a bit, because in this chair video, the Maloof video, I did not cover it at all. I just held up a finished style, and I had some comments of people wanting to see a little more about it, wanting to know how they were fabricated. And the two chairs use the same design for styles. They're a little thinner and slimmer on the Windsor than they are on the Maloof, but the same design, same technique. So I go into that in a fair amount of detail. So we'll pick up after the seat has been carved and go from there. The basic difference between a seat in a Maloof chair and a Windsor is the way things are attached to it. In a Maloof style chair, it's all attached, everything's attached with a shoulder joint. But on Windsor chairs, the signature feature of a Windsor chair is the legs are attached with a tapered tenon, a wedged tapered tenon. It's basically, this is one of the legs, very unfinished, a lot of work left to do, but it does have the tenon on it. So it's basically a cone-shaped, a circular tenon that fits into a cone-shaped mortise on the chair. And when it reaches the end of that taper, it just locks in place, won't go any further. It's an ingenious design because the act of sitting in the chair reinforces the joint. The wedged part is you cut a slit in and when you pound it into the chair, you put a wedge from the other side into that slit, and you pound the wedge in, and it spreads the cheeks tight against the mortise and really makes it snug. The way you make this is you rough out this shape on the lathe, and then you finish it with one of these. It's basically it's called tenon cutter, and it's basically like a big honking pencil sharpener. This excess wood here, this long straight part, won't be there when the chair's finished, when the leg's finished, because after I've done a nice taper shape to this, I'll be able to run this tenon cutter further up the leg and basically move the taper further up and reduce this length here. A lot of work left to do there. My legs are rather simple, just a simple curve. I do contemporary Windsors. Traditional Windsor would have a lot of fancy flutes and stuff, and that's not my style. That's not what I do. But people get intimidated about how to drill those holes, because nothing in this chair is a right angle or a straight. Everything's a compound angle. Everything attached. The legs are they splay to the side, and then they have a rake forward. So there's two angles involved here, and people get, how do you do it? Well, there is a technique to do it that makes it quite reliable. Now, if you look at the picture of the blank before it was carved, you'll see there's all these lines on it. These are sight lines, and they're integral to how you drill these holes. Now, obviously, you can't see me do it because I've already drilled the holes on this and it's all been shaped, but I use the same technique when I taper these holes. These are parallel holes right now. They're not tapered yet. So when I cut the tapers for these holes, I'll use the same technique. And you see the sight lines are still in place on the underside to serve that purpose. So we'll go into that technique at that point. Some of the other things I've done, I've made the back posts, okay? What is going on here? What is all this excess wood? The reason for this is I like to use faired joints on my Windsor chairs. Faired joints are those organically shaped joints that you see on Maloof chairs. I use a fair joint where the legs meet the rocker and where the armrests meet the back post. And to make a fair joint, you need to have a lot of excess wood on the two parts you're joining together. And once they're fastened together and glued up, you sculpt away the excess wood to make the fair joint. Now, I only need the excess wood on one side of this post, all right? But I can't turn it on the lathe like that. It has to be balanced. So I have the excess wood on both sides. And then once the shape is done, it'll be a rather simple shape. It'll be straight, and then it'll taper down to a nice curve at the end. And once I have that shape, I'll cut off the excess wood on one side, and with spoke shaves and hand planes, I'll smooth it out so that it'll be a nice cylindrical continuation of the cylindrical shape all the way through. But here on this side, on one side, you'll still have a whole hunk of excess wood to work with. Now, I've cut the tenons on both ends. This is where the headboard attaches. This is where it inserts into the chair. I've cut these tenons, pre-cut them before I finished this on the lathe. All right, it's just a lot of turning left to do here. I do that. That's not how most chair makers do it. Most chair makers size these tenons directly on the lathe. I don't like to do that because I often overshoot it, or it's fussy to sneak up on it, and it's probably because I'm not as skilled a turner as all these other chair makers. So very likely the case. So I cut them initially for a perfect fit. I do that. There's a lot of ways to do it, but I do it with a tenon cutter. You can find them all over the place, but typically the ones you find are really big. They're 2 inches, 2.5 inches. They're for making fence posts, tenons for building fences, and obviously that's too big for an application like this. But Veritas Tools makes some miniature ones that are perfect for chairs. Okay, if you want to look those up, get those. Those are great. They're kind of expensive, but they're high quality. Veritas is a class act. But I don't have those. I use one of these. This is a weird looking tool, isn't it? It's a tenon cutter. Dates from about 1850. It's made from by E.C. Stearns and Company, Syracuse, New York. I think they went out of business in the 1920s. They were really big in the late 19th century, making funky tools like this back in the day when most things were handcrafted, before machinery took over a lot of this production. It's a weird looking thing, but it has one advantage. Unlike tenon cutters nowadays, one tenon cutter cuts one size, right? This thing cuts several. It'll do 1 inch down to 3/8 of an inch. And it's pretty interesting. It just has this iron in here. It works kind of like a block plane. This iron here cuts perpendicular to the grain. I mean, you just fit it on there and turn it with the hand brace, and this shaves it away, and you get a nice tenon. The nice thing about this that modern tenon cutters don't do is this is adjustable. Not just the size, obviously, but you can fine-tune the cut by tweaking the position of this iron. I like to make it a little. You can make it super snug, but you don't want it too snug. There's a very specific fit you want for these. You want this to be able to. You want to be able to put this in with your hand, but you don't want any wiggle in it. Now this is a perfect fit. There's no wiggle. You saw it winning quite easily. When there's glue involved, it'll be a little snugger and it'll require a few light taps with a mallet, but it'll go in just fine. You don't want it too snug. You don't want to have to pound like crazy with a mallet to get in there, because if it's that tight, you risk splitting the seat. And obviously, if it's too loose, it's going to wobble around, and no amount of glue will fix that. So the other thing that's nice about this antique tool is you can adjust, like I said, you can adjust you can fine tune the cut. You can make it so it's super snug and you get a glassy smooth tenon, or you can tune it down for just not quite as snug. And when you do that, it leaves this really rough surface, which is actually intentional. I like that because these are put in with epoxy glue. And epoxy likes a rough surface. With a rough surface, it gets a better grip, okay? So, a nice side benefit of this tool. You can get these online on eBay. They're pretty common. Just look for tenon cutter, you'll see them. Look for that bizarre tool, and they're pretty affordable. There's tons of them out there. You gotta be careful. This is in really good shape, this one. A lot of them come pretty beat up, pretty rusty, but if it's all cosmetic, who cares? The functional things you want to look for is you want a good iron. It has to be good and be able to take a nice clean edge. And the screws, all these set screws, there's 4 of them. They'll be chewed up and stripped. You don't want that. You want really good, high quality set screws, and all 4 of them. You don't want to be missing one. There's this little depth gauge. You rarely find these on it. They're usually lost or broken or something. It doesn't matter. I mean, sorry, off the camera there, right there, little depth gauge. I never use it because the furthest it goes down is 1 1/4 inch. I never cut tenons that long, so it's just interesting tool. Before you can use this, you have to taper the end of what you're cutting first in order to get this to engage. A lot of ways you can do it. You can whittle it. You could do it on a belt sander, or you could use one of these. These are dowel pointers. Oh, I'm sorry. Hold them up to the camera would be a help, right? Dowel pointers. This is what you typically see. It's like 2 1/4 inch. Again, for fence building and stuff. Small ones like this, which are generally more useful for chairs, these are harder to find, but you can go on used tool sites and find these things. These often are pretty beat up. You gotta be careful and get one with a good iron, and it's not too sad of a shape. You know, a lot of these out there are real junk because they're basically ancient and they've been through the wars. So I said I was going to explain how you do the hole drilling with the compound angles with that special technique I talked about. And then I went and got really cooking in the wood shop, and I did it all without ever turning on the video camera. My bad. But none of this is glued up yet, so I can take it all apart and walk you through the process. So let's do that now. So if you remember, I drilled the holes from the front as perfectly parallel holes with the compound angles intact. And then later I would taper those holes from the back using the exact same technique. And that's what I've done, and that's what I forgot to videotape. So we'll just walk through it here. All you have to imagine is the sight lines drawn on the back of this. And you can see them on the template. So basically, it's like the template has little pinholes in it where I put a little finishing nail through and like a little tap and dent the blank, telling me where I'm going to drill the holes. And then there's another pinhole here so I can draw the sight lines to it. The sight lines are, if you take, if you start turning this, at some point, the leg's gonna, from your perspective, it's gonna look like it's going straight up and down. That's the sight line. If you draw a line straight back from there, straight across the back of the chair, you get the sight line. So the sight line eliminates one of the angles. So all you have to worry about is one angle. And it's written on the template. For the front legs, it's 14 degrees. For the rear legs, it's 23 degrees. So you take a bevel guide. For the front leg, you set it to 14 degrees. And you, remember there's a sight line going right about here. You take the bevel gauge and you put it right on the sight line. So now the blade of the gauge tells you how the brace has to line up. So you drill the tapered tenon with one of these. Okay, it's a angled cutter. It matches the angle used here to cut the tenon on the legs. These legs are done, by the way, and turned. There's a hole in the end for the dowel. The tenons are finished. I've numbered them all. They're all indexed to the proper hole with numbers. I'll explain these other lines in a moment. So basically, to stick this in here, I mean, there's a bit of a curve you have to account for here, but this leg lines up with the blade of the bevel gauge, with the bevel gauge lined up on where the sight line was. So when you drill, you set that there like that on the sight guide, and you drill and you keep the brace lined up with the blade, both in every way. Just keep it perfectly lined up with the blade, and you get a perfect compound angle for your mortise for the leg. And that's really the trick. And it takes a little bit of practice, but not much, because it's not really that complex. Obviously, the trick making chairs is getting a good sound template. And I don't have any secrets for you there. If you can't swipe one from another chair maker, you just got to do a little experiment. You got to build a chair or two and experiment and sort of dial in all your values for the template. So, but once you have a good template, you're good to go. So the holes have all been drilled. It's sitting on, it's raised up so that I have room to pound these legs in. So now I've drilled holes for the spreaders, and let's talk about the spreaders a little bit. The spreaders are the rungs that go between the legs. You saw in that picture, this picture here. A lot of people misinterpret what those are about. They call them rungs, and they think, oh, they're holding the legs together, but they're not. They're called spreaders, and they're pushing the legs apart, which seems counterintuitive. And a lot of people didn't know about this trick for quite a long time. See, the art of handcrafting Windsors was kind of a lost art for a while. I mean, back in the 18th, 19th century and before, I mean, these were always mass-produced, but they're mass-produced by hand-built craftsmen. A lot of specialists. You know, so there was one person who carved the seat, one person who did the turnings, one person who assembled them, one person who painted them. So all the chairs would move around to these specialists, and then eventually they would make it to Windsor, England. This is where they get their name, which wasn't where they were made. It was the market town through which they moved on their way to the primary market, which was London. We're talking like 17th century, 18th century. Windsor didn't come to America till the early 18th century. Governor of Massachusetts, I think, was the first one to import a Windsor chair, and they just became wildly popular in this country. Americans began making Windsor chairs by the boatload. Anyways, so how was this secret figured out? There was an interesting guy, Mike Dunbar. He's like the granddaddy of Windsor chair artisan artisan chair makers for Windsor chairs. He was a liberal arts student in the 70s, and he came across this antique Windsor at, I don't know, a garage sale or a yard sale or something. He became utterly fascinated by it. It was a very old chair. He found out later that it was a 200-year-old chair made by a craftsman in Boston, but at this time, all he just knew it was a very old chair. It was comfortable, it was incredibly light, incredibly strong, and it was still tight as the day it was made. Now, these chairs were put together with hide glue, and I can't tell you, for 200 years, that glue has dried up to nothing. It's gone. There's no glue holding that chair together anymore, but it still was tight. What was the secret? The secret was tension. He didn't figure this out till they actually took an antique chair apart. Then the secret was revealed. The legs are pushed apart. So we'll just do one side here. So what you do after you've drilled the holes for the spreaders, these are 3/8 inch holes. Let's see, one of these. I'm trying to find which one. It's this one here. What I do is I measure, I pound these in really snug, and then I measure the distance between the holes, between the bottoms of the holes. I use something like this. Hold on. One of these deals. Okay, I put a little pieces of wood on the end so I can reach all the way down to the bottom of the holes. Because what you want to know the precise distance between the bottoms of these holes. And I take that length and I add 1/8 of an inch. And then I cut my blanks for the spreaders. I turn them I put these are the 3/8 inch tenons on the end, cut with that funky antique tenon cutter I showed you. So when they go in, when you assemble the chair, when you pound everything in, and you pound it in snug, they're pushing the legs apart. Because if you think about these joints, the only thing that'll kill a circular tapered tenon is wiggle. Okay? Once a little bit of play, it doesn't have to be much, it can be almost imperceptible. Once a little bit of wiggle develops in the joint, that's it. It's not a question of if it'll fail, it's only a question of when. It'll eventually fail because a circular tenon is not an optimal glue surface. It's only half of its optimum. The rest of it's like side grain, end grain. It doesn't really, it's not a good, it doesn't hold with glue really well. But the tension keeps it all tight. So, anyways, I'll move on and I'll talk about the top. So the legs are finished. The legs and the spreaders, they're done. They're ready to be glued to the bottom of the chair. But they don't do that quite yet. The next step is I like to fit the arms and the arm posts. I won't glue them on, but I'll fit them all. I'll get them all ready. Because it's easier to do that with, I can just set the seat blank flat on a bench like this and not have the legs on it. So when I finish them, I'll glue the legs on, then I'll glue and the next step is I'll glue the arms and the back posts. I'll do all that in. But how do I do these? I've done some preliminary work on the arms. I've cut them from 1 3/4 inch lumber. I've taken off a 3/8 of an inch on the top and the bottom, resulting in a piece, it's 1 inch thick. There's a lot of markup on here to guide me in shaping the arms. There'll be a nice scallop shape here. I'll taper the underside of the bottoms, refine the edges, taper this up a little bit. A lot of shaping left to be done. It'll be all shaped and sanded and ready to go before I attach it to the chair, with the exception of the end here. The end will still be pretty rough like this because I need this excess lumber to shape the fair joint. You'll see that I've already removed some because I've attached it to the post already. There's a screw that runs through here, and a 2.5 inch screw runs and goes right into the arm. That's where most of the strength of the arm attached here comes from. There'll be glue too, but most of the strength comes from the screw. So I can stick it right there, and I could rough out the shape of the fair joint. I cut all this excess off on the bandsaw because removing it with rasps is very laborious. So if I can get rid of a lot of it on a bandsaw, yeah, that saves me a lot of work. So you hear me call them fair joints. It's the name actually comes from boat building. They do a lot of this stuff in boat building. Fairing a curve, they call it. There's two kinds of curves. There's symmetrical curves and there's asymmetrical curves. A symmetrical curve is take a circle or an oval and split it into 4 pieces, and those are symmetrical curves. They're symmetrical to their matching quadrant. An asymmetrical curve is one that's more organic in shape. There's a lot of curves like that in boat building, and so they call it fairing a curve, attaching a piece of wood to a specific part of the boat. Some people call these Maloof joints. I don't like using that term. He didn't invent them. Nobody knows who invented them. Morton Escherick was doing these kinds of joints decades before Maloof came along. He didn't invent them. No one. I've seen pictures of ancient Egyptian furniture with joints like this. So they've been around a long time. Giving Sam Maloof credit for it is ridiculous. He's a fine woodworker, but he didn't invent these. So I call them faired curves. So critical is the hole underneath where the post is going to attach. This is not the post, by the way. I'll explain that in a moment. It has to be precise. It can't be off very much. Maybe a 0.5 millimeter, fine. But you get more than that, you start getting a problem with this glue. I said earlier that tension in a chair is good. It helps keep it tight, but you can overdo it. If this isn't precise, then this joint is under too much pressure. It's not optimal. There's going to be a little bit of tension no matter what you do. You just don't want to overdo it. So what I do, You know, different designs, a lot of chair makers, they will drill a hole right through the arm, and then with a long auger bit, they'll go right through, and then they'll drill the hole here. So now they're perfectly lined up, right? It's a perfectly fine technique. It's great, but it does result in a visible circular tenon at the top here, which is fine if that's what your design wants. I mean, a lot of chairs do it, and it looks very, very handsome. But that isn't what this design has. It's not visible at the top. So how do I get that precise position? All I do is I put the posts in the chair and I attach the arms to them like this, and I position them exactly the way I want them, you know, just perfectly, you know, level or whatever, and exact position I want on the chair. And then I have the dowel in there, and I do the old sightline trick. I just position it so the dowel is to my eye, perfectly straight, vertical, up and down. And that gives me, I can just mark back here in the back of the chair, I can mark the end point of the sight line. I know the angle it has to be, it's 25 degrees. So I now have, obviously this thing, if it's not, it's either touching the bottom of the arm or it's very close. If it's very close, I just put a straight edge under there to bring it all the way up to touch the bottom of the arm. And then I can just mark on 3 sides the outer circumference of a 7/8 inch circle. I can then reduce that down to the size I want. So I now have the drill point, I have the sight line, I have the angle, and I do the drilling in the drill press because I don't want to use an auger bit. I use a Forstner bit for this. Auger bits have a really long tap screw on the end, and so it goes quite a bit farther than the actual bottom of the chiseled hole. And this is only 1 inch thick, so I don't want to go too deep. I don't want to go so far that I risk coming through here as I shape the arm. So that's the way I do those. So that's it. After I finish fitting these things and they're all ready to go, I will glue the legs on, and then I'll glue the posts and the arms on. And how do I get the exact length? Again, I use one of these things to get the exact distance from the bottom of the hole to the bottom of this hole. And I use the exact length. I don't add to it like I do for the spreaders. Then I know the exact length. I cut the blanks, I turn some arm posts, and it's ready to go. So now it's time to move on to the headboard. Like all curved, in a Windsor chair, the headboard is curved, and traditionally in a Windsor chair that would be curved with steam bending, but I don't do steam bending because it poses logistical challenges for me. So I do all of my curved shapes as laminations. Now in the Maloof video, the only curved part of the rockers, and I do those with laminations, but because they're narrow strips, I just clamp them to a form. But the headboard is, basically laminations are like strips of wood all stacked together and then fastened to a form. You slather glue in there and you fasten it to a form, and when the glue cures, it holds the shape of the form, and it's very strong. It's very, very strong. It's stronger than steam bending. It's the strongest curved construct you could make. But the headboard, it's 6 inches wide. All right, is the pieces for the blank, and that's too wide to clamp to a form. I mean, you could try it, but it never works really well. You get some gaps, and it just starts to delaminate on you. The preferred way of doing laminations on anything that's more challenging than a thin strip is with a vacuum press. And it's pretty straightforward. Vacuum atmospheric pressure is extremely strong. I think it's like 1,200 pounds per square foot at sea level. That's a lot of pressure, and it's perfectly evenly distributed. Basically, you put the form and the piece inside a very tough bag, airtight bag, and you attach a vacuum pump to it, and it sucks all the air out and bends the piece to the shape of the form it's sitting on. Also, you can put the form outside the bag and clamp it to the form, and either way. It depends on the form you're using, how big it is and how unwieldy it might be. But for this one, I have a big curved form here, and it's inside the bag, and this will be inside the bag. And the procedure's fairly straightforward. I will tape take pictures of it and walk you through it. I won't do it here in video, it takes too long. And also, once you start with the glue, you don't want to slow down. You want to power through it. You want to get it done quickly because you don't want the glue starting to set up before it's in the bag and under the pressure on the form. So once you get started, you really have to move along quickly. So I'll take pictures if I go and talk it to you. But basically, I use white glue, not wood glue, because wood glue dries brown, but white glue dries clear. So if there's any slight hairline in the laminations, you're not going to see it with the clear white glue. But a tight bond glue dries brown. You'd see a visual seam. If it's done right, you have to closely inspect the laminated piece to see that it's done in layers. You do it by, first of all these pieces are registered. They're from one piece of wood, cut out in a bandsaw. Some people these can be kind of challenging to make because they have to be thin, no thicker than 1/8 of an inch, really. If you get them thicker than that, it can be really hard to bend them into a curve. But they have to be perfectly even and preferably a nice smooth surface on both sides. That can be challenging to get with some equipment. You can't really easily put these through a thickness planer. What I do is I resaw them on a bandsaw. I have a really good bandsaw that resaws really well, and I get a nice consistent thickness throughout. It's a little rough here, but not so rough that I don't worry about it. It's going to laminate very nicely. But if you get a really rough surface from a bandsaw blade, that can cause little visible seams to show up. When I used to do that, I used to put it through the thickness planer, but you can't put a piece this thin through a thickness planer safely. The stress of going through will tend to rip the wood apart. So what I did was I built a sled that was perfectly sized with slight ledges on all four sides to register and hold the piece in place. And so it's put under stress from the cutter head, but it's spared the stress of being pulled through the planer by the rollers. And I found that was often enough, but I would always have to make a few extra because there was always a risk that one of them or more would get torn up going through the thickness planer. So I basically have avoided doing that now. I have a really good resaw blade, and I have a really good bandsaw, and I retune it up really well. You get a nice consistent thickness, and it works well. There's other alternatives. You could put these, this is too wide for one pass through a table saw, but you could put it, this is 6 inches, so 3 inches on the side. You could do this on a table saw, preferably with a thin curved blade to save some wood, and make 2 passes on either side, and with a little bit of strip left uncut, because you don't want to cut it completely off on the table saw. You want it still in one solid piece, and then you take that last piece off at a bandsaw, and then you maybe hand plane it or something to get that. It's a bit of work, but there's alternative ways to produce these. But what you do want is a nice even thickness. This is a perfect 1/8 of an inch all the way, all over. Okay, and then slather a bunch of white glue in there with a roller, and then I wrap it in tape. In the middle, the tape is just taped, just straight up taped around. But on the end, you don't do the tape on the piece. You wrap it so that the tape sticks to itself. It forms a loop so that it holds it, it registers it. So as you're putting in the bag, they don't slip and slide and lose their orientation. But because they're not taped on the ends, when you put it on the curve, they can slip a little bit from the end and produce a nice low stress curve. As I said, once you start putting the glue on, you can't dilly-dally. So that's what I'm going to do. I'm going to get this set up. Oh, and you always wrap it in plastic because you don't want the glue squeezing out on your form. Gluing it, if you don't do that, you'll glue it to your form, which is kind of a disaster. So you wrap it in plastic, and so it all goes in, it's all self-contained inside the bag. And then you just suck the air out, and I let it sit for a nice long time. Technically, the glue sets up in a half hour, but No, I let it go for a couple of hours. I make sure it's really solid before I take it out of the bag. People say, you know, how does the glue cure if there's no air in the bag? Remember, the wood itself is sucking the moisture out of the glue, so it works. Trust me, it works fine. A lot of people do this. Vacuum presses are really the standard now for laminations. It works really well. So we'll be back. So after I got the lamination for the headboard done, I basically just laid the chair across it like so, and just marked out the outline of the headboard. Pretty easy. And I just cut it out on a bandsaw. So now we're going to deal with the refining of the shape. So I'm going to begin the final shaping of the headboard. It's pretty basic. I'm going to smooth out all the edges. I'm going to put a slightly rounded bevel on the two bottom edges, and on the top back edge a slightly rounded bevel. No, I'm sorry, on the front edge I'll put a slightly rounded bevel. On the back edge I'll put quite an extreme rounded bevel, giving it a really pleasing shape, and I'll also do the same on the ends here. I do it all with spoke shaves, and I put it in this carving vise here to work on it. It's just got two rubber padded jaws that are articulated so that they can move around and hold odd shapes quite well. I'm going to have to address the question that I'm going to get. Well, if I don't address it, I am going to get it. There's going to be all kinds of comments, and it's going to be, why don't you use a shaving horse? That's the traditional tool, right? That's the traditional technique for this. Well, the main reason I don't use a shaving horse is I don't have room for one. I have a small shop, and shaving horses take up quite a lot of space. I experimented with a shaving pony once, which is basically a miniature version that attaches to your bench. I didn't like it very much. I didn't care for the experience, so I abandoned it and I went to this. But the other comment I made, it's a traditional tool, right? Well, no, it isn't. Not for Windsor chairs. You know how I know? Because that's what Mike Dunbar says. This guy would know. He researched this stuff extensively. They did something more, the traditional craftsmen of old, they did something more like this. They put it in a vise and did all their shaping. Why? You know, shaving horses, you can move things around in a shaving horse really fast. That's their claim to fame. But if you ever watch someone use a shaving horse, they move things around in them a lot. They're constantly moving the piece. With this, you can shape three sides in one go just by moving the tool around, and you only have to flip it once to do the fourth side. So which is faster? I suppose you could do all kinds of tests and everything and time it and all this, and maybe some people would use a shaving horse faster than this, but the craftsmen of yesteryear chose this, and you can bet they did it because it was faster. Because these guys weren't artists; they were journeymen, they were tradesmen. It was just it was a trade to them. It's like carpenters frame houses and plumbers install pipes. These guys made Windsor chairs, and most of them were specialists. It was rare that back in the day that one person made an entire chair soup to nuts. They usually were specialists. There was a person who carved the seats, another person who did all the turning, another person who assembled the chairs, another person who painted the chairs. And these guys are fast. I read an article somewhere like a good chair painter could paint a chair in 5 minutes. 5 minutes! I can't even imagine how you could paint one of these things that fast. So these guys were good, and it was all about speed because they were paid by the piece. So if they chose a technique, you can bet it was because it was faster. It wasn't art, it wasn't a fine art to them. I mean, the reason the craft died out was because when factories came along with machines, it was cheaper to make them in factories. And so the hand techniques were just abandoned until Mike Dunbar researched and retrieved them in the 1970s. So I see a lot of websites where craftsmen wax rhapsodically about the romance of traditional techniques, and they often talk about the shaving horse. And if you're going to do that, you sure you're actually talking about a traditional technique? Because where Windsor chairs are concerned, the shaving horse wasn't really used. But that's just an interesting bit of trivia, really. I mean, bottom line is, if you enjoy using shaving horse, use a shaving horse. I mean, what the heck? We're doing this because we enjoy it, right? So whatever works for you. I do it this way. Okay, so now I'm going to get to the making of the styles for the back, which is some reason I said I started this whole video, because a lot of people in my previous video commented, they wanted to know how they were made, because I didn't go into it on the aloof chair video. For those people, when you see how it's done, you're going to kick yourself, because it's not hard. It's pretty straightforward. I have here a piece of cherry that's 1 inch thick, exactly 1 inch thick. I started out as rough 5/4 cherry, and I milled it down to on the thickness planer to exactly 1 inch, because the style. So the width of them on this chair is 1 inch. I then drawn out the side profile. There's 2 templates. There's the side profile, and there's the front profile. So it's just, I've marked them out, 7 of them. There's 7 styles, and I'll just cut these out on the bandsaw, and then the next step is to do the front profile, lay this out on them and cut them out. But before I do that, what I'll do is I will smooth out the surfaces, particularly the face of it, from the saw blade marks from the bandsaw. I want it to be nice and smooth. Not as important to do the back, but I do it anyways, just for thoroughness. And once they're all, I do that then because as they're straight, it's easier to clamp them and work them with the spoke shave. After that's done, I'll mark them up with the front profile and cut them out again. Cut that out on the bandsaw. And then I'll be back to show you the rest of the steps. So the styles are, the rough finishing of the styles is done. The side profile has been cut out of the bandsaw, and then I inscribed the front profile on those cutout pieces and cut out the front profile on the bandsaw. Okay, I've smoothed the sides with a spoke shave, but there's still a bunch of work left to do. I'll do on the routing table. I'll do a 1/2 inch round over on the back, both sides of the back, giving it a nice curved back, and that'll be the only tool work left. Everything after that, everything is handwork. I'll do a slight round over on these edges here, of the front, just to give it a nice feel. The bottom, where it attaches to the chair, is going to have a 1/2 inch wide, 1 inch long round tenon, cut with the same funky tool I showed you before. The top is going to have a 3/8 inch wide, 1 inch long tenon. All right, but these have to be cut to length. So how do we do that? First of all, we mark where the holes are going to be drilled on both the deck of the chair and the headboard. Now there's 7 of these, so one of them goes right smack in the middle. So you just find the center line and you mark it. Now you need 3 more evenly spaced holes on either side of that. So you do that with one of these. And I think these are called a divider, I'm not sure. But you twiddle with the distance between the points till you end up with 2, you could just do 3 perfect steps, perfectly even steps from the center line, and mark 3 perfectly evenly positions for the holes on either side. And you do that down there at the base too, and the deck of the chair. So now you have the location of the holes. Now you just need the correct alignment for the holes. All right, and you get that by literally just placing the styles here, and you mark the line of it on the headboard. So the angle increases as the styles move across the chair. For the headboard, you just put it in the carving vise, and you drill the holes with a hand brace, sighting down those lines you drew. For the alignment of the holes in the base, you pound the headboard on, and you stand it up, and you drill the hole sighting down the lines on the headboard, right all the way down to the seat. I put an extension on the hand brace to do that. It gives me more clearance up here at the top, so this can clear the post more readily and make the drilling a little more efficient. Without it, this is way down here, and it's just closer to the post, and it just clunks into things. You still get a little obstruction, but makes it a little easier. The last thing you do is you actually cut these to length. each one. And it's very simple. You allow for 1 inch at the bottom and 1 inch at the top. So where this meets here, you just add 2 inches, and that's the length of this. So you cut it off, you do the tenon on the top, and you're ready to go. But you don't glue it up until you've finished everything here. You finish everything to its final grit, sanded. You want it all perfect. Because once these styles are in place, it's too hard to get in there with sandpaper. So we make it perfect before we glue it all up. And we glue it all up with epoxy, of course. So it's all glued up. It's done with epoxy, as I've said. This is the stuff I use. System 3 T88. You can use whatever you like, but I recommend a long cure 2-part epoxy for 2 reasons. Long cure is generally stronger than fast cure epoxies. And 2, you want lots of time to deal with issues if they come up. And here we have a classic case. What is this clamp for? Well, as I was twisting the style into the hole, it snapped off. And I can't stop. All the epoxy's in the holes, and you know, I got to keep going. So I just a little bit of wood glue there and a clamp to hold it in place, and I'll clean it up later. What's this clamp for? Well, you want, after you put them in, you want to turn them orient them so the faces form a nice curve across the back of the chair. But this one didn't want to cooperate. It kept wanting to, I turned it to a curve, and it kept wanting to turn back. So I just, you know, put a clamp here, just twist it and hold it in place till the glue dries. So what's with all the tape? The tape is to control squeeze out, because you don't want to have to clean up epoxy. It is a thankless, tedious job. And if you can avoid it, by all means. So I put down the tape to control the squeeze out. It's kind of the consistency of honey, so it spreads out across the deck. So tape there to catch that. And up here I have tape in case any of the epoxy runs down the holes, out of the holes and on down to the style a bit. So I just have that there to catch that kind of stuff. I still had a little bit of cleanup to do because I smudged a little bit of epoxy around as I was positioning these in the holes. Mostly here on the bottom where you can't really see it. So I'll clean this up nonetheless, but it's the only place. I also have a little bit here to clean up. I think I'll do that now before it dries. These can be tricky to get in. It's kind of like a Chinese puzzle because they don't line up with the holes. They want to spring forward a little bit. On this chair at least, they wanted to spring forward about a couple of inches. An inch or 2 maybe, and so you're trying to line them all up and you're trying to get them all in, and they're springing out as you move the headboard around. It's a good idea, if you can, to cut it so that each one is just a smidge longer. So the longest one here, and they get progressively shorter as you go across. That way you can start at one end and like at the long end and work your way across, and they all sneak in a succession. If you don't do that, and it doesn't always work, you still end up with a kind of a Chinese puzzle thing. But if you don't do that, you end up trying to fit them in, and they're all springing out on you all over the place. It can be a real hassle. And the more you're doing that, the more you get smudges and stuff with the epoxy. Yeah, it doesn't always work, but it's worth a try. So, there you go. So the last parts to be made are the rockers. And they're a load-bearing part, and they're curved, so it makes lamination is a really good solution for them, because lamination is a very, very strong construct. So I have here the wood for one of the rockers. It's 10 strips, each one exactly 1/8 of an inch thick, so that adds up to 1 1/4 inches in thickness here. I will end up gluing some additional laminates in strategic locations to form the pedestals for the legs of the chair, to give me some wood there to do the fair joint. You notice they're indexed to the order they came off the table saw. This allows, when it's nice flat surfaces, perfectly flat surfaces, and it's a good glue up, what you get is a lamination that's so perfect it's hard to tell it's a lamination because all the grain lines up. So it's a pretty good illusion. You'll notice that I don't use a vacuum bag for these. It's just my opinion. It's a thin, narrow strip. So it clamps up. You can get a good even pressure with clamps, and I just think it's easier to do with clamps than a vacuum bag. It's a big form to fit into a bag, and it's I find this easier. And if yeah, that's a lot of clamps. Maybe too much, maybe overkill, but if you got them, use them. All right, you want good even pressure through the whole thing. You'll notice I've got painter's tape on the form itself, and I got painter's tape on this strip that is here to prevent the clamps from denting the wood of the actual lamination. There's painter tape there so that the squeeze out doesn't accidentally glue it to the form or glue the, so you can so you don't get a mess that way. The mallet is, I keep a mallet on hand when I'm gluing it up because this is a dead blow mallet, so it's not going to damage them. When you're gluing them up, sometimes the laminations want to slip out of register on you, so I'll just pound them flat again with this as I'm gluing them up. They're indexed, so that the wood is indexed and the form is indexed, so that I make sure that the rockers, each one, are glued to the form in the exact same position. All right, this is important, and I only use one form because it's important that the rockers be absolutely identical in shape. In order, if you don't get the rockers right, the rocking chair will tend to walk across the room as you're rocking it. So to do it right, one, the rockers have to be identical in shape. So this solution does that. And two, they have to be attached to the chair in perfect symmetry. And when we get to that point, I'll walk you through the tricks I use to get that done. So when they're all glued up, the pedestals are glued up, and I've milled them down, we'll move on to the next. One thing I forgot to mention, with wood glues, you can normally remove the clamps after about 30 minutes, but with laminations, I don't recommend that. Laminations put a lot of stress on uncured glue, so I wait till they're completely cured. If you take the clamps off too soon, it can begin to delaminate in places, which basically ruins your part. So I wait till it's completely cured. I mean, I use white glue in laminations, and I can see the squeeze out. Some of the squeeze out is still white. I wait till it's clear, completely cured, then I'll remove the clamps. Takes a bit longer, but it's definitely worth it. You don't want to risk wrecking your laminations by being impatient. So I've milled the rockers down to the dimensions I want. It's 1 1/4 inches high and 1 1/4 inches thick. And the pedestals are still in place. It's still rough on the ends, but now we want to make these mate perfectly with the chair. The front legs in this design with my templates, the front leg usually meets really flush with the surface, but this one's usually way out. So you have to sand this down to be flat with this. You can do. I'll do the rough, because it'll be off by quite a bit. And I got to take like almost 1/4 inch off on one edge, one side of it, but not like right here. It's like kind of like a little diagonal. So you have to be careful because you want it flat in both ways, meeting this. I'll take the bulk of it off with a orbital sander, being very careful. Just really sighting it down and making sure it's in the right position, and just slowly take it down. But when you start getting close, I recommend you put the power sander away and do the rest of it. Dial it in with a sanding block. Because you don't want to overshoot it, and it's very easy to overshoot it, or overshoot it on one side. Then you got to take it more on the other side. Then you got to take it more, and pretty soon you're finding you're having to adjust this because now it's leaning too far this way, and you're getting a gap at the front. So, easy does it. Slow and easy wins the race here. But these are pretty good. I got these pretty lined up. They meet the legs pretty flush. All right, they haven't been attached. So eventually, we're going to want to mark these up with the holes that I'm going to drill for the dowels. But before we do that, we want to position it. Find the position it's going to be on the chair. It's the symmetrical positioning that I talked about, so that the chair doesn't walk as you're rocking it. So let's get to that. So this is how I set the rockers symmetrically on the chair. I place the chair on the rockers. It's just balanced on them, so it's a bit rickety, so I use these clamps just to help them stay in place. I have a piece of tape on both ends of the bench that are right angle to the bench, and I can line the legs up on those pieces of tape. And then I put another piece of tape at a right angle, perfect right angle on the bench, back here under the rockers. So the basic idea is you want, at a given distance from the back, from the legs, you want this height from here to be identical. If you can get them identical, then you know that the rockers are symmetrical. So it's basically, I just put the ruler on the edge of the tape and I measure the height to that point in the rocker, and I do it on both sides. And I just twiddle with the position of the rockers, of the chair and the rockers, and as I move them forward and back on them, the rockers tend to inch up and down in the back. And you just keep doing that, dialing it in until you get these to be identical heights at the given location from the back of the chair. Once I've done that, then I just mark up the rocker with a circle of where the leg meets the chair. And you can see I've got two lines here because the first one I did it once, and then I thought on this rocker back here, I didn't have enough. It was too close to the front. Probably could have pulled it off, but I wanted a little extra wood at the front in order to shape the front of the rocker. So I redid it to move it a little further back on the rockers to give myself more room on that one right there. So I have marked the position of the holes by putting inserts in the legs and positioning these and giving them a whack with the mallet. So now I have little dents in here to tell me where I'm going to drill the holes. Then I need the line of the holes. So I just place this here and I use the dowels I cut as a straight edge to draw lines that I'll use on the drill press to tilt the bed of the drill press, so I get nice, holes that line up with the dowels. Once I've done that, I will put it back on and I will just do a final fit, and hopefully I won't have any mistakes at that point. And then mark up the excess wood here that I'm going to cut away on the bandsaw to alleviate some of the work when I shape the joint. I also have to trim these to length. Now that I know where the leg meets the chair, I can measure out here an equal amount on each rocker and cut off this excess. I'm going to mark up here where I'm going to remove the wood, and also mark up the shape of the front of the rocker. It comes out about an inch here from the leg, and then it curves under. I will also route the shape of it. It's just be a bit of a curve up here at the top, and then a 5/8 inch round over on the bottom. Now when you route these laminated pieces, you have to do what's called a climb cut. If you don't, you're going to get a lot of nasty tear out. Laminations do not get along really well with routers if you're not careful. A router, if you read the manuals, they'll tell you don't never do a climb cut. They won't use that term. What they'll do is they'll tell you always go to the right when you push it to the right, because if you look down on a router, the bits are turning clockwise, so the cutting edge is entering the wood from the left. So you so the action of the router wants to push the router to the left. So if you push to the right, you're working against that, and you get a lot of control. If you go to but a climb cut is the opposite. A climb cut has you move the router to the left, which is the direction the router wants to go by itself. So it can be, the danger is it can get away from you. So as I say, the manuals say don't do that, but experienced woodworkers do climb cuts all the time. There's definitely a use case for them. This is one of them. If you just go the conventional direction, you risk tearing out the lamination very likely. So just, if you haven't done a climb cut before, just go on YouTube, watch a few people doing it, do a few practice runs. The trick with a climb cut is it can get away from you, as I said. So you want to go just a little bit at a time, maybe 2, maybe 3 passes to remove all your wood. Don't try to do it all in one go. That's not safe. The other thing that you won't see in any video that I've seen, no one ever tells you this, you always do a climb cut with a handheld router. Never attempt one on a routing table. If you do, it will not go well for you. At best, it will ruin your piece. At worst, you could do yourself serious injury. So what happens is you can't control the piece. It shoots away from you, and that's that's a pretty scary thing to happen on a router table. So yeah, handheld router. Practice, if you haven't done one before, practice it a few times. Go slow, go careful, get a feel for it. But don't be too terrified of it, because experienced woodworkers do it all the time. So I've finished shaping the rockers with the router, and I've sanded them up. I've shaped the ends, just tapered them in a nice way, and it's been tapered in the front. So I glued them up, epoxy glue again, and I've done the tape around it so epoxy doesn't drip down and mar the legs. Because there will be squeeze out. I strive for squeeze out here because the epoxy glue, which doesn't dry clear, the one I use doesn't dry clear, but it's close to clear. It's got a bit of a tint to it, but it blends in just nicely here. I want a bit of squeeze out because no matter how well you fit these, there's always a bit of a sliver of a crack at some of the legs where the legs meet the rocker. So the epoxy fills that up, and when you shape them, it just goes smooth, and it looks really nice. So attaching them is a bit of a trick. If you try it, you'll notice, oh, yeah, how do you get, because the dowels are going this way, and it's what you always got to start. You always put the back on first, and you force the front in. What I do is I get the back on and I get it clamped down so it's nice and snug. Then I put a clamp right here in the middle and I squeeze it down. This flexes the rocker a little bit and pushes the hole forward a little bit, but it's still not enough. I put on the dowel on the front, I taper the edge of it a little bit so it gets close. And then I just, a dead blow mallet, line it up and give it a whack or two, and it pops right into place. Once it's in, I just clamp everything down tight, and this will be all cured and ready for shaping tomorrow. So the last steps are, I'll be shaping the fair joints where the legs meet the rocker. I'll have to give it a final sanding as necessary, wherever it's necessary, touch-up sanding. Like right here, I need to do a little. And then I'll put the finish on. Osmo Pollux oil is what I use. It's three natural oils and 2 natural waxes. It looks really nice, a little pricey, but I like it. It looks really nice on chairs. And like I said in my other video, I like using penetrating oil finishes for chairs, not film finishes. One, because they're wipe on, they go on a lot easier. It's hard to brush a finish on all these crooks, cracks and crevices and everything. So wipe on oil goes on a lot easier, and I like the wipe on oil. I like a wipe on oil leaves a nice wood feel to the surface, and when you're sitting in the chair, you're touching the chair, it feels right. So that's it. I don't think I'll shoot any more videos. I'll just show you the finished chair when it's done. So the chair came out really nice. I'm really liking it. I really like this curly cherry. It's really quite striking. It really shows up in the seat particularly. The finish came out really nice. It's a very comfortable chair. I find these Windsor rockers more comfortable than the Maloof rockers. And that's just personal preference. Some people are the other way around. The Maloof rocker is a very spacious chair. This one's tighter. You wear this chair more than you do the Maloof rocker. But it came out really nice. I'm really pleased. So please post your comments below, and thank you for watching.